found it. So today we're going to be talking about graphing systems of equations. Yesterday we reviewed graphing single lines. Now what we're going to do is we're going to put two of them together. So a system of equations, I have an example right here. It basically means more than one equation. Okay, a system, whenever you have a system of something that's more than one item put together, and so a system of equations could be two, could be three, could be four. For you it will be two. It will be two. Okay, do they always have to be written in slope-intercept form? No. Okay, it's just two equations. And so real quick, when we graph a system of equations, we can get three different possibilities. And this is on your sheet. And granted, it is kind of small, but that's okay. If you need to add some things, you can. The first thing is if we have exactly one solution. That means they intersect, okay, in one specific point. Okay, we call that a system that's consistent and independent. If you want to abbreviate, this is called C and I. So for your homework, this would be called C and I. Okay, that way you don't have to write consistent and independent all the time. Okay, the other thing, this second one, what do you think is happening on the second one?
It can be any number along that line.
It's just a slope intercept.
Because notice I don't have two lines.
Should be any point along that entire line.
I don't have two lines that I can see. Actually, this is both a red and a blue line. It's just one is on top of the other. It's the exact same line. So if it's the exact same line that you're graphing with the exact same slope, exact same y-intercept, that one is called consistent and dependent.
C and D?
Okay, that's an infinite number of solutions. It can be any solution along that line, C and D, yes. And then last but not least is if these two lines never intersect. These two lines will never intersect if they are parallel, which means same slope, different y-intercepts. Okay, and we call that one inconsistent. So those are some things you're going to have to file away to memory. One solution, consistent and independent. You might want to think one solution is similar to an I. Okay, one kind of looks like an I, so that would be your clue, C and I. Consistent and dependent is a bunch of solutions. And then inconsistent, no solution. Okay. So now let's go ahead and look at the next slide here. Maybe. Okay, there we go. It says use the graph at the right to determine whether each system is consistent or inconsistent, and if it is independent or dependent. So let's go ahead and look. So what you're going to have to do is you're given these two equations. You're going to have to locate on here what two equations you're looking at. So first of all, negative 2x plus 3. Negative 2x plus 3 is here in the blue. So this is the one I'm looking at right now. And granted, yours isn't in blue on your...
No, it's the green one. It's the green one. That's
It
2x.
is the blue one. 2x. Oh, negative 2. Oh, sorry. Yes, you're right. Okay. I thought it said 2x. I didn't see it said negative 2x. Negative 2x plus 3 is the first one we're looking at. Okay? And then we have x minus 5. So we're looking specifically at the green and the purple lines right here. What do you notice about the green and the purple? They intersect in how many points?
One.
1. So I think 1, I know that one solution is
C and I.
C and I. So that's what you would write. Okay? So far so good?
So far great.
All right, let's look at the next one. Use the graph at the right to determine. Same exact instructions. Negative 2x minus 5 is what one?
The green, the blue.
Red. Negative 2x plus 3 is what?
Blue. Green.
Green. So we're looking at the red and the green right here. You notice about the red and the green?
Inconsistent.
They're inconsistent. Very good. So inconsistent is that one because they are parallel. Okay.
Don't be so silly.
Okay, oops. The next one, what I want you to do is go ahead and figure out what one that one is going to be. Okay, you figure that one out. X minus 5 and negative 2x minus 5. If you want to, it might help to look up here at the board since it's in color. So back group, back there. C and I, good. It's exactly one solution. It is right here. All right. So now what we're gonna do is we're gonna get to where we're actually graphing these. And so on the very first one, it says graph each system and determine the number of solutions that it has. If it has exactly one solution, we're gonna name it, and we're gonna actually say the solution is this point. So the very first one we're gonna look at, okay? Y equals negative 3x plus 10. What you're gonna wanna do is find the slope and the y-intercept of each of these. So what's the slope gonna be here? Negative 3. What's the y-intercept?
10.
10. So what I'm gonna go ahead and do is I'm gonna go ahead and graph that line. So a y-intercept of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's try that again. 7, 8, 9, 10. Okay, there's my y-intercept of 10. Now I need to graph a slope of negative 3, which means I do what?
Down 3 over 1.
Down 3 over 1. Down 3 over 1. So if I go ahead and draw my line in, okay. There we go. I'm going to go ahead and adjust that line a little bit. So it's a little bit. There we go. Okay, next one. I'm going to graph in a different color this time around. And so I'm going to go ahead and graph y equals x minus 2. I'll actually use peak. So what's the slope of my second line?
Negative 2.
1. Good. What's my y-intercept?
Negative 2.
Negative 2. So at negative 2, I'm going to put a dot. Slope of 1 means you do what?
Up
1 over 1.
Up 1 over 1. Up 1 over 1. So if I go ahead and draw my line in. Ooh. What do you know about this? Yep, it has one solution. Now what they want us to do is they say if it has one solution, they want us to name it. So the solution here is this point. What are the coordinates of that point?
3, 1.
3, 1. So first of all, it has one solution, and the solution is at 3, 1. You need to make sure you put that in as an ordered pair.
What's the 1 point?
That's one solution. I could even, here. That better?
Yeah.
Okay. So far, so good? Let's go ahead and look at the next one then. Ooh. What do you do on this one? Yeah, you're gonna have to do a little work first before we can actually go through and find this. So let's go ahead and subtract 2x on this first one. So I end up getting negative y equals negative 2x minus 1. Now what do you need to do? Divide by negative 1. So I end up getting y to equal what?
2x plus 1.
2x plus 1. Good. So now slope is what?
2.
2. What's the y-intercept?
1.
1. So let's go ahead and plot those. There's a y-intercept of 1. Slope of 2 means you do what? Up 2 over 1. Let's go ahead and draw that line in. Okay, on the next one, what are you going to need to do? Subtract 4x, yep. So I'm going to subtract 4x. So I end up getting negative 2y equals negative 4x plus 6. What do you need to do now? Divide by negative 2. So I end up getting y to equal 2x plus what?
Negative 3.
Negative 3. What's my slope? 2. What's my y-intercept?
Negative 3.
Negative 3. So I'm going to put a dot at negative 3. And then I'm going to go up 2 over 1. Now, real quick, and this is something I'm going to kind of teach you to do. This is a hint. Once you find that slope and y-intercept, compare it to the first ones you found. okay? So if I compare it, I notice that the slopes are what?
The same.
The same. So this is the thing. The lines are either going to be parallel or it's going to be the same line. So when I find the y-intercept now, I notice that it's different. So what can you tell me about these lines? Are they parallel or is it the same?
Parallel.
They're parallel. Okay, so you know right away that my solution, there isn't going to be one if they're parallel. Okay, now granted, you still need to go through and draw in the line. Okay, but that's kind of like a little thing you can do, a little tool you can use in order to find your solution. So this one is actually inconsistent, and so how many solutions does this have?
No solution.
So 0 solutions. So 0 solutions is gonna be what your answer is here. Okay, you could put no solution if you wanted, that would be fine. All right, let's look at the next one. The next one's a little bit nice. The first one is in slope-intercept form, the next one isn't. What's the slope gonna be?
Negative 2.
-2. Okay, what's the y-intercept?
Negative 3.
-3. So here I'm at -3. What do I do from -3? Down 2/1. Good. Okay, let's go ahead and draw that baby in. Now on the next one, we need to solve. So what do you need to do first?
Subtract 6x.
Subtract 6x, good. So I end up getting 3y to equal -6x minus 9. What do I do now?
Divide by 3.
Divide by 3. So you get y to equal what?
Negative 2x minus
-2x minus 3. What's your slope?
Negative 2.
Slope is -2. What's your y-intercept?
Negative 3.
-3. So let's compare. What do you know about the slopes?
The same.
They're the same. What do you know about the y-intercepts?
Same.
They're the same. So what can you conclude?
Infinite
It's the
solution.
same line. So if it's the same line, this is the one where it was infinitely many solutions. Okay, it was C and D, but what we need to put is we need to put infinitely many solutions. Okay, infinitely many solutions. So on this part, you're either gonna have 0 solutions, 1 solution in which you name the point, or infinitely many. So on the first bunch, remember we have C and I, which means how many solutions? 1. C and D, which means how many?
Infinite.
Infinitely many. And inconsistent, which means how many?
0.
0. Okay. All right. Do you think we need to look at that last one? Or you think you're good?
We're good.
Good? Okay. All right, here you go. Now, a little bit about this. It looks like a lot, but what I did is I kind of chunked it. You have 10 through 15, which is like the first few that we did. Okay, so that's 6 problems. You have 18 through 24, which is another 7, and then you have another 4. So it comes out to be roughly like 17 problems.
Not that bad.
So it's not that bad. It looks worse than it is. So that is due tomorrow. Tomorrow what we're gonna do is we're gonna do a worksheet on section 6.1 to make sure that you have a firm basis on this before we move on.